Okay. Okay. So we have draw the signal, I think, as I can remember. Okay. So there is a sequence. Okay. From N1 to minus N1 to N1. Okay. And as I can remember, okay, I can't remember exactly. We have draw the signal repeated sequence like this again. Okay. After some time, we have uh, the repeated sequence. We have wrote something like this. Okay. So that repeated pattern is wrong. Okay. In that question, repeated pattern is wrong. Okay. But don't worry, all steps are correct. Okay. All the steps are correct, but that repeating pattern is not correct. I have drawn the repeated pattern. Okay, this is actually here in this question we are asked to find the Fourier transform. Okay, not the Fourier series representation. Okay, so Fourier transform is for non-periodic sequence. Okay, so this is a non-periodic sequence. Okay, only this sequence is there. Okay, so anyway, we have repeated this sequence. Okay, but that repeating pattern is wrong. Okay, so that is what I want to tell you. Okay, but don't worry, the steps are correct. Okay, all the steps we follow are correct. Okay, but now I can't remember this pattern. I draw the pattern, repeated pattern. That pattern is not correct actually. Okay, so don't worry. So anyway, I hope if you are given any repeated sequence, now you should be able to find the discrete time Fourier series representation. That's all. Okay. So another one is I think I have asked you to. So this is our book. Okay, this is our reference book. Okay, this is our reference book, and wait a minute. Okay. Yeah, this. Okay, so this equation we have learned. Okay. Sorry, this is a continuous time periodic, continuous time we have learned for the discrete time. Frequency analysis of a discrete time. Okay. So actually this equation we have learned so far. Okay. This is the discrete time complex exponential Fourier series representation. Now you should be familiar with these two equations. Okay. Okay. So I think I have asked you to do this question by yourself. Okay. This example 2.2, as I can remember. So have you done, and can you do this by yourself, or do you need any help? Can anyone feedback? Have you done these questions? And so what I want to know is, can you do this kind of question by yourself? Okay. So the answer is given. Okay. So should I do this again? Or can we skip this part? Can anyone feedback, please? This is the periodic sequence. Okay. This is a periodic sequence. Okay. Okay, okay, I will do this. Actually, I haven't do this. Okay, I haven't do this. I just ask you to. I just ask you to try to do this. Okay. So okay, I will do this. Uh, okay. So try to do this with me. Okay, and try to understand all the things. Okay. So we are given discrete time periodic square wave signal. Okay, like this. I will take that signal. Okay, so this is the periodic signal. Okay, so this is the periodic signal. You are asked to find, okay, you are asked to find, you are asked to find uh, discrete time, complex exponential Fourier series representation for this periodic signal, for this periodic sequence, okay, for this periodic sequence, okay. So we will try to do it, okay. Uh, So already you know that any sequence, any given sequence, any given periodic sequence Xn can be represented as a sum of complex exponential terms Jk omega naught n, okay, with the weightage Ck. This Ck is referred as Fourier series coefficients. Fourier series coefficients, you already know that, okay? And this K should be from 0 to n naught minus 1. That is enough for discrete time. Okay. But for a continuous time, this will be from minus infinity to plus infinity. I show you how this come from 0 to n naught minus 1. That is enough. Okay. So any sequence can be represented as a collection of complex exponential terms like this. Okay. And this omega naught is equal to 2 pi divided by n naught. Okay, this n naught is the period. This is the period. Okay, and this k is from 0 to 1 to like this up to n naught minus 1. Okay, so that is that. Okay, then you can estimate this Fourier coefficients using this identity 1 over n naught. Here it is n from 0 to n naught minus 1 xn e to the power minus jk omega naught n. Okay. So this is the two identity we need to use to find the discrete time complex exponential Fourier series representation for a signal. Okay. mm, this, okay? So I have right now jk omega naught. Okay, so here instead of omega naught, they have write 2 pi by n. Okay, so I have right here, no? I have right here omega naught is equal to pi n naught. Okay, so instead of omega naught, they have right here 2 pi by n naught. Okay, so they take n as the period. Okay, in this book, n is referred as period. I have put n naught here. Don't worry. Okay, that is how I used to put the uh, notation. Okay, so instead of this omega, they have put 2 pi n naught, 2 pi n. Okay, and here it is minus 1 over n naught. Okay, so these equations I have right here. Okay, so these are the equation you have to use. Okay, okay, these are the equation you have to use. Okay, okay. Now tell me, uh, can anyone tell me what is the period of this signal? What is the period of this signal? What is the period of this signal? Can anyone tell me what is the period of this signal? How we can find the period? How we can find the period? So you have to use two consecutive repeated point. Okay. Okay. Two consecutive repeated point. Then you have to calculate the number of sample. That is how we are going to find the period of any signal. So what is the period of this signal? Can you understand what is this signal? Okay. So actually they are given some value without exact value, just a variable value, L and N. Okay. So this L means here the 0, 1, 2, 3, 4, 5, 6 like L here. Okay. So this once we have up to L minus 1, no? This point should be L minus 1. Okay. This is L. So this point should be L minus 1. Okay. Then we have 0 value. After that we have 0 value. Okay. Then here N is there. Now it is repeating. No? Okay, so you can see that this point is repeating here again. Okay, for example, this L may be 2. Okay, and this L may be N may be 5 or something. Okay, so the signal will look like this. Okay, you have 1, 2, 0, 1. Okay, so L is 2. No? So that means L is here. Okay, then N is 5. So 1, 2, 3, 4. Again here 5. Okay, this kind of sequence, no? This kind of sequence you will have if L is equal to 2 and N is equal to 5. Okay, so you will have this kind of sequence. Okay, okay. Now tell me, what is the period of this signal? What is the period of this signal? Please tell me. Tell your answer. If it is wrong or correct, no, don't worry. Just tell me. What is the N here? What is the period of this signal? No, the answer is wrong. Okay, answer is wrong. Actually, I am asking the period of this signal. Okay, I am asking the period of this signal. Okay, so I just take two. Don't get confused. Okay, this is the signal we are given. This is the signal we are given. Okay, so I just take example. Okay, I just take example by putting exact value for this L and N. Okay, okay. So I just put exact value for L and N. Okay, for example, I assume that L is equal to 2 and N is equal to 5. Okay, okay. So if I draw the signal, okay, XN signal with this value, exact value, okay, the signal will look like this. Okay, signal will look like this. Okay, so here we have n value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so on. We have n value. Okay. So here I assume that L is equal to 2. That means L is before 1, no? Okay. So we have here. Okay, so this point will be this. The last one point should be L minus 1. Okay, so it will be 0 and this one, L minus 1, this point. Okay, and this will be there. Okay, this will be there. That is 2. Okay, then we have 3, 4. Again, 5 is one value. 5, in 5 we have one value. Okay, then 6 also we have one value. Then 7, 8, 9, 10 again we have one value. 11 again we have one value. 12, 13, 14, 15, we have again one value. Okay. So this kind of sequence we will have if we take some value to this L and N. Okay. So here they are given general value, L and N, not exact value. I just put some exact value and draw the signal, okay, to have understand, have understanding. Okay. So now I have asked the period of this signal. Okay. Okay. Okay, don't worry. Tell me what is the period of this signal? What is the period of this signal? So one student has given answer for this signal. Actually, that answer is not correct. Okay, think it again. Think it again. What you have to do is you have to select two repeated points. Then you have to calculate the value. You have to calculate the sample between the two repeating point, two consecutive repeating point. That is what you have to do. So can you tell me what is the period of this signal? This is the example signal. Okay, this is the example signal like this. Yes, yes, that is correct. Okay, just think again. It is not 7 actually. For the signal period is not 7. It is the period. Yes. Okay. 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 So I will tell you how to find. Okay. So I got some answers. Okay. Only one answer is incorrect. Others are correct. Okay. So you can see that. Okay. So what you have to do that you have to select two consecutive repeated point. Okay. So if you can select this one, this one is repeating where? At here, no? This is repeating here. This one is repeating here. This is the sequence. Then that sequence is repeating again here. That sequence is repeating again here. That sequence is repeating again here, like so. Okay. So this is the sequence. So that sequence is repeated. So this is the repeated sequence. Okay. So what you have to do is you have to select two consecutive repeated point, this one and this one. Then you have to calculate the sample from here to here. That is what you have to do. So the number of sample is 1, 2, 3, 4, 5. So the period is 5 for this example. For this example, period is 5. Okay. Then what is the period of this signal? Actually, we have to we have to find the Fourier coefficients of Fourier series representation of this signal. So for this signal, what is the period for this signal with general value? Tell me then what is the period for this signal? Maybe you can compare with this one. Maybe you can compare with this one, and now if you compare with this one, you may be possible to identify the period of this signal. I'm asking this signal, okay? Okay, I got some answers, okay? Okay, the first thing is that, okay? Okay, we will see, okay? Okay, the first thing is that, okay? And so actually this L and N are general value. L and N are general value. Please try to understand this, okay? I think this maybe the way of giving this question may be wrong, okay? Okay, actually here they have put some general value, L and N value, okay? So here according to this signal here, if you count this 1, 2, 3, 4, 5, 6, L is equal to 6, okay? And N is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equal to 10, okay? Actually that is not correct, okay? Because they are putting some general L and N value, okay? So between this sample, there may be some sample, okay? So they have, I think it is like this, okay? You have this kind of sequence, okay? Up to here, this point is L, okay? Then you have some sample and again repeating. So this point is N, okay? So this kind of signals are there, okay? So this is L is not exactly 6 here and N is not exactly 10 here. They are some general value. They can be anywhere. For example, here I take L is equal to 2 and N is equal to 5. So you will have this kind of signal, okay? So if you take L is equal to 6 and N is equal to 10, you will have exact this kind of signal. Did you get this? ඒක තේරුණාද? මෙතන මේ L and N දීලා තියෙන්නේ general value එක. හරි? ඒ කියන්නේ මෙතන අපිට L කියන එක 6යි කියලා ගන්න බෑ. මෙතන දැන් ඔකට ගණන් කරපුවාම එන්නේ 6යි. 1 2 sorry බිංදුව 1 2 3 4 5 L sorry L කියන්නේ 5. හරි? 5 එනවා. 6 7 8 9. N කියන එක 9 එන්නේ. sorry N කියන එක 9 එන්නේ. හරි? L is 5 and N is 9. L is 5 and N is 9. Okay. ඇත්තටම මේක එහෙම නෙවෙයි. මේ L කියලා දීලා තියෙන්නේ මෙතන මේ ජෙනරල් වැලියු එකක්. ඒ කියන්නේ මෙතන මේ තව සාම්පල් තියෙන්න පුළුවන් මැද හරි. හරි? මැද හරි සාම්පල් තියෙන්න පුළුවන්. එතන අර ටික් ටිකක් තියලා නැහැ ඒක. They haven't shown it, okay? So that is the only thing, okay? තේරුණාද? එතකොට මේ L කියන්නේ මේ සිග්නල් එක ගත්තාම L කියන්නේ 5යි N කියන්නේ 9යි කියලා ගත්තොත් වැරදි. මේවා general value. These are general value. So don't take this as some values, okay? By counting, okay? For example, if this kind of signal, maybe L is equal to 5 and N is equal to 9, you will have exactly this kind of signal, okay? Exactly this kind of signal. Okay, so many students has identified that this L is 5 and N is 9, and they have given the answer. Most answers are correct. Okay, but here we have a general sequence. Okay, so this length we don't know exactly, and this N also we don't know exactly. Okay, so in general case, what is the period for this signal? Now we have a general case. Okay, not a certain case. It is just a general case. Okay. So what is the period of the signal? For a general case, what is the period of this signal? I hope you got it, no? මේක මේ L and N දීලා තියෙන general value එක. Exact value නෙවෙයි. ඒක general case එකේදී තමයි අපිට xn වලට representation එක හොයන්න කියලා තියෙන්නේ. හරි. එතකොට අපි general value ගන්න ඕනේ. L n කියලාම ගන්න ඕනේ. Then we will have the period using L O N, L and N. Okay. So what is the period for this signal? So when L is 2 and N is 5, you will have 1, 2. The, the, the period is 1, 2, 3, 4, 5. When N is 5, the period also 5. Okay. So what is the period for the general case? For a general case, what is the period? The period is N, no? Okay. Because here it is starting from 0, no? So if you have count this 1, 2, 3, 4, 5, 6, 7, here this N is there. So the period also will be N. Okay. So the period also will be N. So the period is will be N here, not 9. Okay, not 9. It is just N. Okay. So most of the student has uh, identify it as 9. Okay. So you have identified it as 9 by calculating this value. Okay. So N is here 9. No, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 9. Okay. So if you have calculate the, so if you take this one and this one, if you calculate the sample between this one and this one, between this one and this one, okay, the sample will be 1, 2, 3, 4, 5, 6, 7, 8, 9. You will have 9 sample between this one and this one. So that is the period. Okay. But now exact, that is not N actually. So that is exact value. But this N is a general value. So the period should be N. Did you get this? The period of the signal is N. Did you get it? Any problem? Okay. So if you have any problem, you can ask me. Okay, don't worry. So the period of this signal is N. Okay. So we have find the period. Now what you have to find? Now you have to find, okay. Now you have to find the period is N. Okay. The period is n. The period is n. This is the period. Now you have to find the complex Fourier series representation. To find the representation, first you have to estimate this Fourier series coefficients. Okay. To estimate this Fourier series coefficients, you have this identity. Okay. So you can use this identity to estimate the Fourier series coefficients. Okay. So there are the period is n. The period is n. So the k should be what? K should be, the k should be 0 to n naught minus 1. So k should be here 0 to 0, 1, 2, 3, so on up to n minus 1. This is the k value. Okay. So you have to find C naught, C1, C2, so on up to Cn minus 1. These coefficients you have to find. Okay. So this n is, if we are given exact value, for example, if we are given n is equal to 10 or 9, okay. So you can calculate this value up to C naught to C8, okay. So that value can be calculated, okay. But this n is not given exact value. It is a general value, okay. So you have to get the general, uh, expression for Ck, because n, we are given n as a general value, okay. So you should try to get the general value for Ck, okay. Okay, so we will try to get it, okay. So what you have to do is, you have to use this one, okay. So if you use this one, you can directly write Ck is equal to 1 over n naught. So that is 1 over n sigma n from 0 to n minus 1 xn e to the power minus jk omega naught n. Okay, jk omega naught n. Okay, so you know that the C naught, if you consider C naught, that is k is equal to 0. If you want to find C naught, that is k is equal to 0. So you will have C naught. Okay, so C naught will be 1 over n sigma xn n from 0 to n minus 1 e to the power minus jk is 0 omega naught n. Okay, so can you get the expression for this C naught? I think that is easy, not much difficult. Can you get the expression for this C naught? Please take 5 minutes and try to get the value for C naught. 5 minutes, around 5 minutes, and try to get the answer for C naught. So that is easy, not much difficult. Okay. So what you have to do is, so 1 over n is there. Okay. So you have to expand this value. Okay. So it's 0. Okay, I will do this. Okay, so just try by yourself. Okay, try to get the value for C naught. Take 5 minutes and try to get the value for C naught. Okay, so can you get the answer for the C naught? Okay, so you have to, so what you have to first do it, you have to expand this, okay? So it is not much difficult, okay? So you can expand this, okay? So 1 over n is there, okay? Then, so e to the power minus j k. Now k is 0. In this case, C naught k is 0. So this k is 0, okay? So e to the power 0. E to the power 0 is 1, no? Okay? So you will have only n from 0 to n minus 1 xn, because e to the power 0 is 1. Okay, so you have to expand this one. Okay, so if I expand it 1 over n, okay, so when n is 0, x0 plus x1 plus x2, so on up to x n minus 1. N minus 1 means up to here, up to here. I have to get up to here. If I get n, so that will be, this point is repeating here. So I will get a repeated point, okay? So only sequence I have to consider this one, up to n, up to this point, okay? 0 to n minus 1, 0 to n minus 1, okay? So I have to evaluate it up to this one, n minus 1, okay? So you can see that xl, xl plus 1, this is xl, this is xl plus 1, this is xl plus 2, xl plus 3, so on up to, okay, so xl, then xl plus 1, then xl plus 2, then xl plus 3, so on up to xn minus 1. All values are what? All these samples are equal to what? All these samples are equal to what? These samples, what is the value of these samples? From L to n minus 1. These are the samples. So what is the value of this sample? XL, what is the value for XL? That is 0. No, XL is 0. XL1, this point, that is again 0. XL2, this point, so 0. XL3, this point, 0. So on up to xn minus 1. This is the point xn minus 1. Okay, so you have to get this general value. Okay, don't assume this L and N are some values. Okay, so up to xn minus 1, you will have 0 value. Okay, so what is 1 up to 1 values you have what up to this point, no? So that point is what? What is this point? What is this point? Can anyone tell what is this point? What is this point? This point is L. Then what is this point? This point is XL. So what is this point? This point is L. That means the value is XL. Okay. So this point is, what is this point? What is this point? May point එක මොකක්ද? This will be L minus 1, no? Yes, correct. Okay. So this will be L minus 1 point. Okay. So corresponding value will be X L minus 1. So you can see that, okay. You can see that, okay. So x0, x1, x2 up to x L minus 1, okay, up to x L minus 1, these values are 1. These values are 1, 1, 1, 1, 1, so on, okay. Then, not 1 actually, no, the values is A, sorry, the values is A, okay. it is not 1, the values are A, okay? So you will have A here, A here, A, so on up to XL minus 1, A, okay? So others are 0, no? Okay, so if I have write it again, okay, I will have 1 over N, okay, X naught plus X1 plus X2, so on up to XL minus 1. Then I will have XL plus XL plus 1 plus XL plus 2 up to Xn minus capital N minus 1. Okay. So you can see that this value X0 is 1, X2 is 1, X3 is 1, X4 is 1, 4, so on. XL minus 1 is also not 1A, okay? X0A, X1A, X2A, X3A, so on up to XL minus 1A, okay? The value, okay? So the value of this point is A, this one is A, this one is A, up to this one, that is it. Then from XL, from this point, okay, so this is 0, 0, 0, up to N minus 1, it is 0. Up to N minus 1, it is 0. So this is 0, this is 0, this is 0, this is 0, okay. So you will have this kind of one, no? 1 over N, A plus A plus A up to A. So this is from 0 to L minus 1. Then you will have 0, 0, 0, so on. Okay. So what is the value of this? What is the value of C naught? You will have how many A's there? How many A's there? So it is starting from 0. For example, if L is 5, 0 to 4 values are there. 0 to 4 means again 5 values, no? Okay, 0 to 4 means again 5 values. Okay, so it is starting from 0. So up to here, from this one, L minus 1 plus 1. So that means you have L number of A's, no? L number of A's, okay? So A into L values you will have here, and N is there, okay? So C naught you will have AL divided by N. This is the C naught value, okay? This is the C naught value, okay? Then we will find other value, okay? So you can see that, okay? If you are going to find C1, the E terms will be there. If you are going to find C2, E terms will be there. If you are going to find 3, E terms will be there. Okay. So this E terms will be there. Okay. E terms will be there. For example, okay. If I write C1, that is K is equal to 1. Okay. K is equal to 1. That is C1. So it will be 1 over N sigma N from 0 to N minus 1 Xn e to the power j k n omega naught minus j k omega. Okay. So this value you will have. Okay. So you can see that. Okay. If you are expanding this, you will have x0. Okay. So here e to the power n is 0. No. Now k is 1. Okay. Here in this case k is 1. K is 1. Here n is 0, so this n is 0, e to the power 0, that will be 1 plus x1 e to the power minus j n omega naught plus x2 e to the power minus j, sorry, n is 1, okay, here n is 1, minus j omega naught. Here the n is 2, so 2 omega naught, x3, here 3, minus j3 omega naught, so on. You will have this line, okay. And if you get C2, the same type of value you get, same set of value you will have, okay. But here, this K will be 2, okay. K will be 2, okay. So all these terms are identical terms. The only change is k. Okay, so you can find the general ck value. It is better to find general ck values rather than finding this kind of individual value. Okay, because if we are going to find individual value, you have to find up to n naught n minus 1, cn minus 1. So n minus 1, you don't know exact value. You haven't idea. You don't have idea what is this n. Okay, so this n should be an integer, but you don't know the value. Okay, so it is better to find the general value, general expression for ck. Okay, so we will try to get a general expression for ck. Okay, that means k is equal to k. Okay, the ck, you are going to find the general value. Okay, so 1 over n. Okay, sigma n from 0 to n minus 1 xn e to the power minus jk omega naught n. Okay, so you will keep this k. Okay, because you are going to find general values. Okay, okay, so k will be anything. K will be 1, 2, 3, 5, so on. Okay, but not 0, because we have found the 0. C naught we have found. Okay, and we are going to find other points. We are going to find a general expression for other points. Okay, so if you find this 1 over n, okay, so you will have this kind of one, x0 e to the power minus jk omega naught n is 0. So you will have e0 here plus x1 e to the power minus jk omega naught n, n is 1, plus x2 e to the power minus jk omega naught 2, because n is 2, plus x3 e to the power minus jk omega naught 3, because n is 3. Okay, so on, you will have xl minus 1 e to the power minus jk omega naught n is l minus 1. Okay, then you will have xl e to the power minus jk omega naught l, n is equal to l, plus xl plus 1 e to the power minus jk omega naught l plus 1, so on, up to what? N minus 1. Xn, capital N minus 1 e to the power minus jk omega naught n minus 1. Okay, so you know that from xl, these values are 0, xl plus 1, so on, up to xn minus 1. These values are 0. This is xl, this is xl, and this is xn minus 1. So these values are 0. Okay. So these values from xl, these values are 0. So all these values will be 0. So those values will be cancelled out. These values are 0. Okay. We will have only values up to here. Okay. So x0 is a, x1 is also a, x2 is a, x3 is a, so on. Okay. So you can write it again like this. K is equal to 1. No. Okay. Ck is 1. Sorry. Ck is equal to 1 over n. Okay. 1 over n. Okay. This is 1 over n. Okay. So you can see that this a. Okay. So this a are common. Okay. So you can get out that a here. Okay. So you will have here only 1. Okay. 1 plus here you have e to the power minus jk omega naught. E to the power minus jk omega naught plus e to the power x2 is a, you will get out that a, e to the power minus jk omega naught 2 minus jk omega naught 2 plus e to the power minus jk omega naught 3, so on, up to e to the power minus jk omega naught L minus 1. So this is the general expression. Okay, this is the general expression. Okay, now you can find C1, C2, C3 by putting K here, by substituting the corresponding K value. For example, if you want to find C1, so K is equal to 1 here, 1, 1, 1, so on. Okay, so you can find it. Okay, now tell me, we can simplify, we can get the compact expression. Okay, we can get a compact expression for this addition. Okay, for this addition, how we can get? Can you remember the power series? Power series. Gunottara Sheni. Okay, so this is a power series actually. This is a power series. Okay, this is a power series. This is a power series. Okay, so the multiplier is actually here e to the power minus jk omega naught. This is the multiplier. This is the multiplier. I can't remember. Okay. Okay. So this is the multiplier. Okay. So this is C1 e to the मैं आप වැඩි කරනවා e to the power jk omega naught වලින් මේක එනවා ඒක වැඩි කරනවා e to the this multiplied by e to the power jk omega naught 2 so jk omega naught plus jk omega naught so jk omega naught 2 here if I multiply this one e to the power jk omega naught 2 plus 1 you will have 3 so on you will have this power series. Okay, so this is the multiplier. Okay, and there are L minus 1 terms are there. Okay, so using this power series, okay, if you know the addition of, if you know the expression for the addition of L terms for a power series, you can write the compact equation. Okay, compact expression for this one. Okay, okay. So if you can remember the power series things, okay, addition of n terms, multiplication of n terms, some things we can derive, no, for power series. Okay, so if you can remember, you can directly get it. Okay, but actually, if I have this kind of series, okay, normally I am using Taylor series expansion. Okay, so I will show you. That is how I do it. Okay, but I think Dr. Udesh has done it using power series. Okay, but I'm not, I can't remember the expression for the power series. Okay, so normally if I have this kind of pattern, okay, this is the pattern. So this is a pattern. Okay, so if you have this kind of pattern, okay, so there are some Taylor series expansion corresponding to pattern. Okay, so you can find that expansion. I think that is a general. Okay, so you can find Taylor. You no need to keep remember anything. Okay, Taylor series formula of something. Okay. So Taylor expansion. Okay. So you can see that there are different. So there are different type of expansion. Okay. There are different type of expansion. I will show you maybe here. No. So you can see that. No? So there are different type of expansion. Okay. So you can see that. Okay. So if you have this kind of pattern, okay, and if you want to get a compact expression, okay, you can use this Taylor series expansion, that is also called as Maclaurin expansion. These are under Taylor series expansion, okay? The Maclaurin also some Taylor series expansion, okay? So you can use this expansion, okay? So here I think for our one, this one is okay, no? Because you will have 1 plus e to the power minus jk omega naught. Here the x is equal to, it is just like x is equal to e to the power minus jk omega naught, okay? So you will have 1 plus x, so on, okay? But this is some up to infinity, okay? This is up to infinity, okay? Okay, so you can see that if you consider x is equal to e to the power jk omega naught. Okay, so you will have 1 plus x square plus x third plus x fourth, so on, up to infinity. Up to infinity, the compact expression will be 1 over 1 minus x. Okay, 1 minus x. Okay, so what 1 minus x. Okay, so so this is the one of Taylor series expansion. Okay, this is one of Taylor series expansion. So you can see that if you have infinite number of values like this, you can get a compact expression. You can get a compact expression for the infinite number of terms. Okay, okay, like this 1 over 1 minus x. Okay, okay. Now the problem is that we have a finite sequence. We have a finite sequence, that is L is up to L minus 1. Okay, so you will have like this 1 plus x square plus x third up to x L minus 1. Okay, you will have up to this level. Okay, you will have up to this level. Okay, not up to infinity, up to x L minus 1. Okay, this is L minus 1. So if you take this as x, it will be x L minus 1. If you take these whole terms as x, okay, if you take this as x, okay, so that is up to x L minus 1, okay. So how to calculate, how to get the finite sequence using this infinite sequence, okay. So, so I normally used to get like this, okay. So we have infinite sequence, no, we have an infinite sequence. Now you have to get up to xl minus 1, xl minus 1. So this is how I do this, okay. So I just multiply this expression, let's say that this 1, okay. I just multiply this 1 by xl minus 1, okay. I am just multiplying it by xl minus 1, okay. So you will have, I will have, if I multiply it by this xl minus 1, because I need to get up to xl minus 1, okay. So I will have xl minus 1, 1 minus x is equal to, now 1 is multiplied by xl minus 1. So you will have xl minus 1. Now, if we have up to xl minus 1, you have to multiply it by xl, okay? Not xl minus 1, okay? I am multiplying it by xl, okay? Multiplying it by xl, okay? So I will have xl 1 over minus x, okay? 1 over minus x. Now 1 is multiplied by L, xl, so I will have xl plus x, L plus 1 plus x, L plus 2 plus x, L plus 3. So this is up to again infinity. Okay, this is up to infinity. Okay. Now if you consider the original one, let's say that this is 2. Okay. If you get original, okay, I will write it here. 1 over 1 minus x is equal to 1 plus x plus x2 plus x3, so on, up to x L minus 1 plus xl plus xl plus 1 plus xl plus 2, so on, up to infinity. Okay. So I will take this one. Okay. Now what happen if I subtract 2 from 1? 1 minus 2. If I get 1 minus 2, 1 minus 2, what I have? Okay. So I will get 1 minus 2. Okay. So that means 1 over 1 minus x minus xl 1 minus x. Okay. So I will have, you can see that 1x, x1, x3, xl. Up to here, I have the value. Then you can see that this xl cancel out, xl plus cancel out, xl2 cancel out, xl3 cancel out up to infinity. Those terms will be cancelled out. Okay. So from here, these terms will be cancelled out. Okay. So I will have the value from 1x plus x3 up to xl minus 1. Okay. So this is the answer. Okay. So if I get the terms 1 plus x3 up, if I add the terms 1 from x3, xl, I will have, okay, I will have, if I get common denominator 1 over x, okay. So here also 1 minus x, and this will be 1 minus xl. I just take the common denominator. පොදු කරය අරගෙන සුළු කරා. හරි? 1 minus xl. Okay. So this is the expression. This is the compact expression. Okay. So for this expression, for this expression, okay, for this expression, for ck, for ck, I can get a is there, n is there. Okay. Now 1 minus xl. X is equal to e to the power minus jk omega naught, no? E to the power minus jk omega naught. Okay. So I will have e to the power minus jk omega naught L. Okay. E to the power minus j omega naught L divided by 1 minus xl. That means e to the power minus jk omega naught. 1 minus x. 1 minus xl e to the power minus jk omega naught L. 1 minus x e to the 1 minus e to the power minus jk omega naught. Okay. So this is the compact expression for ck. Okay. Okay. So we can get the complex expression for the ck. Okay. Okay. Here it is further simplified. Okay. So we get this expression. No, we get this expression. Okay. So this, so it is correct. No, because we have minus jk omega naught L. Okay. So instead of omega naught, they have put here 2 pi by n. Okay. So I will write it like this. Okay. Okay. So in the book we have, okay, in the book we have, okay, this ck is equal to a over n, okay, 1 minus e minus jk. Instead of omega naught, they have put 2 pi by n. Okay, so 2 pi L divided by n, 1 minus e to the power minus jk. Instead of this omega, they have put 2 pi by n. Okay, so this is the expression, no? This is the expression they get here. Okay, so our approach is correct. Okay, our approach is correct. Okay, now they have further simplified. How they have further simplified? Okay, so they have multiplied both terms, the denominator and numerator. No, this is numerator and this is denominator. Numerator and denominator by no, I think they have get out the one terms, no? They have get out one terms, okay? Okay. From here they have get out. From here they have get out um, e to the power minus j5kln. Okay, they have get like this. Okay. Okay. To further simplify this, they have get here a over n is there. Here, okay, they have get from e to the power minus jk25l. Okay, so they have get out minus jk5ln. Okay, 5ln. Then this should be 1, this should be 1, okay? To get 1, you have to multiply this one by jk 5l divided by n, okay? So this one multiplied, okay? So when the multiplied, the power will be add, okay? So this one add this one, so this will be minus, this will be plus. So this one cancel out, you will have e to the power 0. So 1 is there, you can get 1, okay? Minus. So here you have 2, 5, no? So you can get minus jk 5l divided by n, okay? So if you multiply this one, e to the power this one, okay? So when these are multiplying, these powers will be add. So minus jk 5ln, here also minus jk 5ln. So that will be added. So it will be minus jk 2 5ln, okay? So this term is correct, okay? Then I get here, I get e to the power minus jk. Instead of 2, 5, I get 5 by n. Okay. So I will have here should be 1. So here it should be plus jk 5n. So when this one multiplied by this one, minus jk 5n plus jk 5n will cancel out. You will have e0. Then you will have 1. Here you have to get 2 5n. Okay. So if I write here minus jk 5n, that means when this multiplied by this one, e to the power minus jk 5n minus 5n minus 5n, jk 5n. So it will be e to the power minus jk 2 5n. Okay. So this expression is there. Okay. Now, how they simplify this? Can anyone understand what they have done? They have used the Euler formula. Okay, they have used the Euler formula. You know Euler formula. Euler formula is Ej theta is equal to cos theta plus j sin theta, or E minus j theta is equal to cos theta minus j sin theta. Okay, so you can see that if you here you will have plus j if you consider this as theta, plus j theta minus j theta plus j theta minus j theta. Okay, so that means plus j theta minus j theta minus no. Okay, so if you minus this one, okay, e j theta minus e minus j theta, this cos term you will cancel out, and j into j, it will be 2j sin theta. You will have this one. Okay, so you can use this result here. You can use this result here for this one. Okay, then you can write this. Okay, ck. Okay, you can write it ck is equal to a over n. Okay, a over n. Okay, so e to the power j theta, it minus e to the power minus j theta, that will be 2j sin theta. Okay, so you will have, okay, you will have, so I am considering this part. Okay, I am considering this part, e to the power jk 5ln. Okay, so this is theta, this is somewhat corresponding to theta. This one is corresponding with, so e to the power j theta minus e to the power j theta. So this will be 2j sin theta. Okay, sin theta. So time sin theta will be k 5ln n. K 5l divided by n. Okay, and it is divided by Again, here also e to the j theta. If this is theta, e to the power j theta. And if this is theta, e to the power minus j theta. So e to the power j theta minus e to the power minus j theta, you will have again 2j sine theta. In this case, theta is k phi n, k phi n. Okay. Okay. And you can see that these terms are there. So here you will have e to the power j k phi ln. Here you have e to the power j k phi n. Okay. So if I take this here, if I take this here, I will have e to the power minus j k phi ln, okay, minus j k phi ln plus j k phi n. Upon to that terms, let's see. And that term is there. No? That term is there. Okay. So it is correct. No? Okay. So I can write this as, okay. So what I have done, I, this සම්මාව කියන්නේ දර්ශක. මේ දර්ශක දෙක බෙදීමක් තියෙනවා. There is a division of two power number දර්ශක. What here now English නම දන්නේ නැහැ. So here we have a, so when this is dividing, the power will be subtracting. Okay, so it will be minus jk phi ln. Here it will be minus jk phi n. So minus it will be plus jk phi n. You will have this one. Okay, so ck you can find as a to the power n. This will be 2j cancel out. Okay, so you will have sine k phi l divided by n, then sine k phi n. Okay, then you will have e to the power, okay, e to the power, okay. So this jk phi n, these are common, okay, these are common value. You can get jk phi divided by n, these are common value. Here you have minus l, okay, and here you have plus 1, so it will be 1 minus l, okay. So this is the answer, okay. This is the general value for ck, okay. So you get the general value for ck, okay. So ck, when k is 0, it is al divided by n, okay. When n is 0, it is kl divided by n. We have found it, okay. C naught, that means C naught. We have found the C naught, okay. So that is al divided by n naught. Actually n, okay, because this is n, not n naught, okay. So al divided by n, okay. C naught al divided by n. Then if k is not equal to 0, otherwise you will have this one, okay. You will have this one, okay. So we have get this expression, okay. Now what they have done is, so these are some complex number, okay. So they take the magnitude of the complex number and square it, okay. They take the magnitude of the complex number and they have squared it, okay. So if you take the magnitude, okay, magnitude, what happened, okay. If you take the magnitude, what happened? So you can see that this terms is a real value. This is a real value, no? So magnitude, you have to square this to find the magnitude. This one is square plus 0 is square root, okay. That is the magnitude. And again square it, okay. So you will have ALN square, that is square root, okay. And here, okay, here, this one is real. So AN square is there. Sine 5KLN, sine 5KN. This also some real value. These two are also real. So you have to square it. If you get the magnitude, square, you have to square it. What about this term? This term is a complex value, no? This term is a complex value. Okay, that term is a complex value. Okay, so what you are going to do is you are going to, this ck may be a complex number. It is just like x plus I1. Okay, then you have to get the square. Okay, ck square. So how to get ck square? X square plus y square, square root again square. So it will be x square plus y square. Okay, so ck. Okay, if you get this square. Okay, so for k is equal to 0, that is AL divided by n. Okay, so that is just a real number. Okay, so to find the square, you will have to x square, y square is 0. So you will have x square only. So this will be AL n square. Okay, because it's a real number. Okay. And if you consider this one, so you can see that this term is a real term. This term is a real term. This term is a real term. Okay, this term is a real term, and this term is a complex. Okay, you know that. Okay, you know that we can represent complex number in real and imaginary axis. Okay, the x-axis is real and this I is the imaginary axis. Okay, so the real part will be x and imaginary part is be y if we consider z. Okay, so this z can be represented as x plus I1. This is a complex number. This is a complex plane. Okay, this is complex plane. You can write this one. Okay, and also you know that z can be represented if this is r. If this is r, okay, r if this is theta, r cos theta, plus I r sin theta. This is y is equal to r sin theta, x is equal to r cos theta. You can write like this also. Okay, this is j. Okay, j is this. Okay, so if you get r here, okay, if you get r here, it is cos theta plus j sin theta. You know that cos theta plus j sin theta is equal to, using Euler formula, it is equal to j theta. Okay, so z also can be represented as this. Okay, so what is this r? R is this value. What is this value? So that is the magnitude. Okay, the magnitude of the z. Okay, so that is equal to r, and it is equal to square root x square plus y square. Now, if you want to get this z square, this will be square also, this will be square, and this will be r square. Okay, so you can see that this part is a real part, and this is the imaginary part. Okay, and this theta is the phase. Okay, and this r is the magnitude. Okay, r is the magnitude. R, this one, magnitude x square by r square. Okay, so if you consider this one, this term. Okay, if you consider this term. Okay, so this is just like the r. This is just like the magnitude r, and this is jk 5n L1 minus L. Okay, so this J is there, and this K, this one is the theta phase. This is the phase theta. Okay, so this is just like R to the power J theta version. Okay, so this R. Okay, so this R is the magnitude. Okay, so you are getting the magnitude square. Okay, you are getting the magnitude square. So the magnitude square will be the square of this one. Square will be of this terms. No? So that means an sine k5ln divided by, write it here. Okay, so I think it is clear. Okay, because you know the complex number. Okay, so ck, if you get this the magnitude square, okay, you will have al divided by n square That is for k is equal to 0. Okay. And for other terms, okay, other terms, only this one. This one is square because this is the phase and this is the magnitude. If you consider this complex number, so it will be A divided by n square sine 25k n divided by 25, okay, sine 5 sine 5 KLN sine 5 KN, okay, sine 5 KLN K5LN K5N 5KLN 5KN, okay. So you will have the, and this also is square. So this is the magnitude of this CK coefficients, okay. So it is given like this, okay. Okay, so that is correct, no? Okay. So our answer is also correct, okay. So try to get this answer by yourself, okay. Try to get this answer by yourself, okay. So you can go through my lecture if you couldn't understand it, okay. So you can get this kind of one for the magnitude square, okay. So you know that this CK is the Fourier series coefficients. This is the Fourier series coefficients. Fourier series coefficients. Okay, this is the Fourier series coefficients. Okay, and you have get the square value. So Fourier series coefficients is a complex number. You know that it is a complex number. Okay, and you get the magnitude square. Okay, so that magnitude square will be like this. Okay, now you can see that in figure 2, this will be plotted. Okay, this CK is plotted. Okay, this one. Okay, so it plotted for different L and N. It plotted for different L and N like this. Okay, so also you can plot this using MATLAB actually. Okay, using MATLAB you can plot this. Okay. Okay. So what you have to do that you have to only code at this CK square. Okay, CK square. So you can type this CK square like this. If k is equal to you have to use the if and then condition, if else condition. If k is equal to 0, the CK is equal to AL divided by N square. Okay. And if else, that means if k is not equal to 0 else, you can plot CK like this. Okay. Then if you plot CK square, let's say that this is square. Okay. CK square with respect to not plot, okay, you have to use stem command. Stem k according to k, this c k is square value. Okay, so very easily you can plot at this and get this. You can try to get this uh, plot in MATLAB. Okay, so you will have this one, this kind of one. Okay, so then you can try to find by increasing this n value. That means n is the sample, no? N is the sample value of the sequence. Okay, if you are increasing the sample n value, the sample value, you will have this kind of one. Okay, okay. So if you get very much sample, you will have this kind of sequence. Okay, okay. So that is it. Okay, so so try to do this by yourself. Okay, then try to get this answer. Okay, if possible, try to plot this in MATLAB. Okay, try to plot this code in MATLAB. If you have any problem, you can ask me. Okay, if you have any problem, you can ask me. Okay, then I can help you. Okay. So this is easily you can code it. Okay, in MATLAB. Okay, then you can see this. Okay, okay. Actually, this is called the spectra, okay? If you plot ck square with respect to k, it is called as spectrum, okay? So here the spectrum is there, okay? This is the spectrum actually of the signal, okay? I will explain it. I will explain it using another example. We will do another one example quickly, okay? Let's say that so so I think now if you are given this kind of one, you should be able to find the Fourier series representation, okay? Then you can find Fourier series coefficients, Ck, okay? Then if you take Ck square, okay? The magnitude of this Ck and square, then if you plot it with respect to K is equal to 0, 1, 2, 3, okay? If you plot this ck square, you should be able to plot it. It will be like this. Okay, so this is called as the spectrum. Okay, this is called as a spectrum. I will explain this later. Okay, why we call this spectrum. Okay, so you should be able to plot the spectrum, this kind of thing, this kind of signal. Okay, so I will take this kind of one. I will take this kind of one. I think I have uploaded an example for this. Okay. Okay, so anyway, if I take this kind of thing, okay, I will take two signal, okay. It is like this. Xn is equal to 2 cos 4 pi n plus 3 sine 3 pi n. Okay. So if I given this kind of signal and ask you to find the Fourier series representation, complex exponential Fourier series representation. Okay. So if you have sine, so this is this signal we use as composite signal. Okay, composite signal, because two sinusoidal signals are added together, okay, to find this one. Okay, so if we have add any other DC component maybe, okay, so let's say that this kind of signal, if you are taking this kind of signal with the DC component, okay, so you can see that DC component, this is a DC voltage, is added to the two sinusoidal voltages if it is a voltage signal, okay. Okay, so this is a DC component and sinusoidal component, okay. So DC plus sinusoidal component are added together to make this sequence. So these are called as composite sequence. If these are continuous, we normally call them composite signal, okay. So this is a composite signal, okay. So if I ask you to find the Fourier series complex exponential Fourier series representation, okay, here you no need to use the principal approach. That means you no need to use this expression, okay. These two identities you no need to use, okay, because if you are going to use this, it will be somewhat hard, okay. But here, so we are asked to find the Fourier series representation of complex exponential Fourier series representation. Okay, so you know that using Euler formula, cos, for example, you know the Euler formula. It is a j theta is equal to cos theta plus j sin theta, and E minus j theta is equal to cos theta minus j sin theta. You know this, okay? So if you subtract this, E j theta minus E minus j theta, you will have 2j sin theta, okay? So sin theta is equal to E j theta minus E j theta 2j, okay? Divided by 2j, this is sin theta. And also cos theta you can get, you have to add them, okay? So you will have j theta plus E minus j theta divided by 2. Okay, this is cos term. Okay, so you can see that cos term and sine terms can be directly expressed as a collection of complex exponential terms. sinusoidal and cos term can be directly expressed as the as a collection of complex exponential terms using Euler formula. Sin hari cos hari තියනවා නම් ඒවා කෙලින්ම Euler formula එක දාලා complex exponential වල එකතු කිරීමක් හරිය කියන්නේ sum එකක් විදිහට ලියන්න පුළුවන්. හරි. අපි complex so in complex exponential Fourier series also we are doing the same things, no? We are expressing our signal as a collection of exponential terms, okay? So sinusoidal and cosinusoidal signal, if cos term or sin term is there, we can directly represent them as a collection of complex exponential terms using Euler formula. We no need to go through the Fourier series representation process. It will be harder, okay? So simply you can express this as a collection of complex exponential terms using Euler formula, okay? So, so we will do this, okay? So this one also you can use in this identity. You have already derived this identity, okay? This one and this one, okay? So using this one you can represent as a complex signal. This one also you can represent as a complex terms, okay? So it is a collection of complex term with the DC component. That is okay. That is the complex exponential Fourier series representation. But we need another one. What is that? We need to find the omega naught. Omega naught that is equal to 2 pi by n naught. So we will have to find omega naught or n naught period. We have to find the period of the signal. Based on the period, you will have the omega naught. Okay, you will have the omega naught. This omega naught we normally referred as fundamental frequency. This is the fundamental frequency. Okay, so you need to have the fundamental frequency. That means you need to have to find fundamental period to represent this as a complex Fourier series representation. Okay, so how to find the fundamental period of this kind of signal? Okay, so we have done this in signal and system, okay, for continuous time signals, okay, but for a discrete time signal procedure is same. I'm not going to explain much, okay, but I will tell you the procedure, okay? So you need to adhere to that procedure, okay? So cos 4 pi n plus 3 sin 2 pi n. 3 sin 2 pi n. Okay, so you can see that, okay, so now you can see that this is a composite signal, okay? So I think at the beginning I show you in continuous domain. At the beginning, I show you on the continuous domain. If we have xt is equal to sine phi t plus cos phi t, this kind of signal, okay? If we plot this kind of signal, we will again have a sinusoidal signal, okay? Because for this signal, this phi is the angular velocity omega. Here, this phi is the angular velocity for this terms, okay? So both are same, okay? So the frequency of this signal and frequency of this sinusoidal signals are same, okay? So if you have added different sinusoidal signal with the same frequency, only one frequency component is there. This is the frequency component, okay? That frequency component is there. So again, you will have a sinusoidal signal, okay? But if you have added different signal, for example, sine, I will write this like this, 2500t plus cos 25150t, this kind of signal. So you can see that this is the frequency for these terms, that is 100. This is the frequency for this term, that is 150, okay? So for this signal, there are two frequency components, okay? Then this composite signal will not be a sinusoidal signal. It will be another signal with another fundamental period, okay? So you have to find the fundamental period of this signal. Okay. So mathematically we do it is like this. Okay. We take two sinusoidal components. Okay. First we take two sinusoidal component. Okay. So here we have only two sinusoidal component in this signal. So you have take that two. Okay. So this is like you can write this as x1n. This is as x2n. Okay. So you can get this two signal. Okay. x1n and x2n. So you can consider. Okay. So if you consider x1n, this signal. Okay. This signal. Okay. So you know that this is 245n. Okay, 45n. That means you can write it as 225, sorry, 252n. This you can write as 251n. Like this you can write. Okay. So what is this? What is this? Okay. So you can consider this. So you know that if we have a signal like 25 f naught n, okay. So this 25 f naught is the omega. Okay, 25 f naught is the omega. This term is the omega. Okay, and f naught you can find as 25 divided by omega naught divided by 25. We have learned this. Okay, so that is why I quickly write this equation. Now you should familiar with this. Okay, 25 f naught is equal to omega naught. F naught is equal to omega naught by 25. Okay, so here if you have this kind of one, 25 f naught n, so this 25 f naught is omega naught, f naught is equal to omega naught divided by 25, okay? And this f naught, we know that this is the normalized frequency. This is we called as normalized frequency in because this is a discrete time signal. N is there, normalized frequency, and it is you will have it the signal frequency divided by the sampling frequency. Okay, so this is we have f naught. Okay, in sampling should you should remember this. Okay, okay, and we know that um, if omega naught is divided by 25, sorry, omega naught is divided by f naught is equal to 1 over n. N naught is the fundamental frequency. So if you have at this f naught, this 1 by n naught here to f naught, you will have omega naught is equal to 25 divided by n. Okay, so this one, and are very important. Okay, so you need to remember these two identities. Okay, we have represent this. We have discussed this many times. Okay, in addition, for a discrete time, you should be remember that this f naught is a normalized frequency. Okay, normalized frequency. And if you get 1 over f naught, you will have 1 over n naught, you will have the frequency. Okay, so this normalized frequency is not in hertz. Okay, this is not in hertz. It is a number of samples per cycle. Okay, because this n naught is the number of sample per one cycle. Okay, okay, okay. So if you consider this x1n, this is this one. That means 2 cos 45n. Okay, so you can consider this 45 as omega naught. Okay, because 25n naught is equal to omega naught. No? Okay, so this term is omega naught. So you can directly consider this 45 is equal to omega naught. Omega naught of this signal. One signal, let's say that it is 1, omega 1. So omega 1 is equal to 45. Okay. Omega 1 is equal to 45. Okay. Okay. Then you can find n naught here. Okay. That means the fundamental period. Okay. Using this one. Okay. So n naught is equal to, using this one, omega naught, sorry, 25 divided by omega naught. This is the n naught. Now using this one, okay, using this one, I can take n naught is equal to 2 5 omega naught. Okay. So here also you can find in let's say that in one is equal to the period of this signal, okay, cos for 5n. Let's say that it is n1. So it will be 2 5 divided by omega 1. That means 2 5 divided by omega 1. That is equal to 2 5 divided by 4 5, because omega 1 is 4 5. Omega 1 is 4 5. And it is equal to 5 5 cancel. You will have half. Okay. You will have half. Okay, we will find it. Okay, so n1 is half here. Okay, and if you consider the second signal x to n, okay, so that is 3 sine 2 5 n, 3 sine 2 5 n. Okay, 3 sine 2 5 n. Okay, so what is the fundamental period? Let's say that omega 2. What is the omega 2 here? That is 2 5. Okay, because this is this one omega. Okay, and if you want to find the fundamental period, let's say that it is n2. So that will be 2 5 divided by omega 2. That means that is 2 5 divided by 2 5. So n2 is equal to 1. Okay, n2 is equal to 1 here. Okay, so what you have to do is first you have to find the, so you have to select two sine or cosine terms. Okay, so here we have two terms. Then you have to find the fundamental period of each sinusoidal component. Okay, for this component we have 1 over 2. For this component we have 1. Okay, then you have to take the ratio n1 divided by n2 ratio. Okay, so n1 is half, n2 is 1. Okay, so you will have this ratio. Okay, now the next thing is you should simplify this as much as possible, but you have to keep this as a division. Okay, don't get decimal value. Okay, so you can simplify this as 0.5, so don't go up to this level. Okay, so just simplify it as much as possible, but it should be as an integer. Okay, so maybe, for example, if we have 3 by 12, okay, so you can get 1 over 3. That's enough. Okay, let's say that you will have 5 over something. Okay, 35. Okay, so you will get 1 over 7. Okay, so don't go beyond this. Okay, okay, but you have to simplify as much as possible, but you need to keep it as a fraction. Okay, don't simplify up to decimal level. Okay, so if you consider this one, we can't simplify this anymore. So 1 over 2 is there. Okay, then if this ratio, okay, this is the condition. Okay, if this ratio is a rational number, okay, rational number, these two signal, the composite signal is periodic. Composite signal is periodic signal. Okay, periodic signal. If this is a rational number, then the composite signal. That means if this division is a rational number, these two signal, composite signal, will be a periodic signal. Okay, and the period you can get by this. Okay, the period N naught is equal to, so if you get this one, 2N1 is equal to N1. 2N1 is equal to N1. So this will be the period. This will be the period, fundamental period of the signal, and this should be the rational. Okay. If it is irrational, irrational, okay. So, uh, so the signal, composite signal will not be a periodic sequence. This is not a periodic sequence. Okay, if it is irrational. So what is rational number? Rational number means any integers are rational. Okay, and if you have any value with two division, the upper part and the lower part should be integer. So this is a rational number. Okay, but sometime, for example, if you consider this 0.3333, okay, you can consider this as 10, 3.333, 10 into 3. Okay, so this is also a rational number. If you have a repeated decimal value, those are also rational number. Okay, but you know that if you get root 2, it will have 1.2543, so on. Okay, so this is not a rational number. Root 2 is not a rational number like this. Okay, and 5 is a rational number because it can be represented as 22/7. Okay, so this 5 is a rational number. 5 is a rational number. I think this is an approximate value, no, not the exact value. Okay, so 5 may be not rational. Okay, you can check it. Okay, if 5 has a repeated value, that means 3 point value, no, 3.147, that kind of value, no. Okay, so if it is repeating, it is also a rational number. If not, it is a irrational number. Okay, so that is how we can identify rational numbers and irrational number. Okay, so if you need more details, please check Google. Okay, okay. So that this is the way. Okay, this is the way. Okay, so this is a rational number. Okay, this is a rational number. So differently, the composite signal period is equal to N is equal to N2. Okay, so what is N1? N1 is half, as I can remember. N1 is half. This is the N1, and N2 is 1. Okay, so 2 over half, so that will be 1. N2 is 1. Okay, for the composite signal, N naught is equal to 1. Okay, N naught is equal to 1. Okay, then for the composite signal, what is the fundamental period? Omega naught, that is 2.5 divided by N naught. So it will be, N naught is 1, so it will be 2.5. Okay, so omega naught is equal to 2.5. Okay, now you have found the omega naught of the composite signal. Okay, okay, xn, okay, xn, you will have 3, xn is equal to 3 plus 2 cos 4 5n plus 3 sin 2 5n. 3 sin 2 5n. So now you have found the omega naught of this signal, of this signal. Okay, so this is a DC component. Okay, so you no need to find the signal for the DC component, because if you add a sinusoidal signal with the DC component, what happens? The signal will be shifted to this way or this way. So the frequency will not affected by this DC component, but the amplitude is affected. Okay, if you add 3 to some signal, if you have plus 3, the signal will be shifted to this side. Okay, and amplitude will be high. Okay, and if you add -3, the signal will be going to this side. Okay, so this is the offset. We normally call this as a voltage offset. Okay. So the offset, this is just the offset. Okay. Amplitude offset is there. Okay. If this is the voltage signal, this is called as voltage offset. Maybe you can remember that in signal generator, we can give some voltage offset. That means we are adding sinus DC component to the signal. So it will not affect to the period. Okay. Just signal is shifted to this side or this side. Okay. So it will be a offset. If this is, it's a plus offset. If this direction, it is a minus offset. Okay. So this will not affect to the signal frequency. Okay. So if you, so you have found the frequency, fundamental frequency for this signal. So that is omega naught is equal to 2.5. Okay. We have found it, this one. Okay. 2.5. Okay. So you have already found this. Okay. You have already found this. Okay. Now you can represent this as a complex exponential terms. Okay. So then you can write this xn, 3 is there. Okay. So cos 4.5n, you can represent using this identity and this identity. Okay. You can directly represent. Okay. So this is a cosine. So 2 is there. Cosine, it will be e to the power j theta. That means 4.5n plus e to the power minus j theta 4.5n divided by 2. So this is that plus 3 sine 2.5n. N is there. Okay. So this will be e to the power j 2.5n minus e to the power minus j 2.5n, and this will be divided by 2j. Okay. So this 2 cancel out. Then you can write this xn as 3 plus e to the power j 4.5n minus e to the power minus 4.5n plus 3 e to the power j 2.5n divided by 2j minus 3 2j e to the power minus j 2.5. Okay. So this is the Fourier series representation. Okay. Now you have to insert the fundamental period here. Okay. So xn is equal to 3 plus e to the power. Fundamental period is omega naught is 2.5. You know, omega naught is 2.5. So e to the power j 2.5 2n. That means 4.5n plus e to the power minus, let's write it as plus j. Okay. Fundamental period is 2.5. Here it will be minus 4. So this will be minus 2n. Okay. 2, 2.5 2n. 2.5 minus 2n plus 3 2j e to the power j. Fundamental period is 2.5. That is 2.5 only. So this will be 1n minus 3 to the power 2j, 3 to the power j, 2.5 minus no, so it will be minus 1. Okay, so I can write this like this using fundamental period. Okay, so fundamental frequency, this is the fundamental frequency, this is fundamental frequency, this is fundamental frequency, this is fundamental frequency. Okay, so if you know that if we represent any sequence as a collection of complex exponential terms, we will have Ck e to the power jk omega naught n. Okay, so if I expand this, it is somewhat like this: C naught e to the power j. K is 0 here, 0 omega naught n. So C naught e to the power 0, that means 1, plus C1 e to the power, now k is 1, so j omega naught 1 n, k is 1, plus C2 e to the power j omega naught 2 n plus C3 e to the power j omega naught 3n. Okay, I just expand this. Okay, this is the Fourier series representation, complex exponential Fourier series representation. I just expand it. So if I expand it, I will get this kind of sequence, no? C4 e to the power j omega naught. Now k is 4 n plus C5 e to the power j omega naught 5n. So on, I will get up to n naught minus 1, up to C n naught minus 1 e to the power j omega naught n naught minus 1 n. Okay, so I will get up to this level. Okay, so if you compare this one and this one, so identical are there, no? So C naught is there. This is the C naught. This is the C naught. Okay, so C1 omega naught and 1. Okay, so this is omega naught, but the 1 is not there, but the 2 is there. Okay, so this will be C2 terms. Okay, so here you will have C2. Okay, C2 term should be here. Okay, so C1 is 0 in this case. Okay, and if you consider this one, now k is minus 2. That means this should be minus C minus 2. Actually, for the discrete time version, we no need to consider this minus 1. C minus 2 you can neglect. Okay, then this is 1. Okay, so this is 1. K is 1. It is like this, no? That means this is the C1. This is the C1. Okay, because here k is 1. So here k is minus 1. So this will be C minus 1. Okay, so you can see that this C minus 1 also you no need to consider, because for a discrete time we will have only plus value, not minus. 1, 2, 3 up to n naught minus 1. No need to get C minus 2 minus C minus 1, C minus 2, C minus 3 also. Okay, but for this continuous time, we have to calculate that part also. Okay, okay. So if you consider this one, you can see that C naught is equal to 3, C1 is equal to what? 3 by 2j. C2 is equal to 1, because here the 1 is there, 1. Okay, so you have find the Fourier coefficients. Okay, so you have represent this as a complex exponential terms, as a collection of complex exponential terms, and also you have found the coefficients, that is C0, C1, C2. Okay, 3, C1 will be 3 over 2j, C2 is again 1. Okay, now if I ask you to find, so you can see that this C0, C1, C2. Okay, so if I ask you to plot magnitude plot, what you have to do? Okay, so these are the CK values. Okay, CK values, then you have to find the magnitude. For example, C0 magnitude. What is the C0 magnitude? That is 3, no? Because 3 is square plus 0 is square root. So it will be C0. Okay, what is the C1 magnitude? Magnitude of C1. So it will be 0 is square plus 3 by 2 is square, no? 0 plus 3 by 2 is square, because this is the j term. Is square root. So you will have 3 by 2, this magnitude. C2 magnitude is again 1. Okay, so if you plot the magnitude plot, this is k from 0, 1, 2. 0, you will have 3. 1, it is 1. 2, it will be 1.5. 3 over 2. This is the magnitude plot. And if you plot phase plot, okay, you will have 0, 1, 2 phase plot. Now you have to plot the phase of this one. Okay, so what is the phase of C naught? Normally consider like this. Okay, so you know that this C naught is in the real axis, because it is a real value 3. Okay, so C naught this one. So phase is 0, no? Here the phase is 0. And C1, phase of C1. So C1 is 3 into 2, okay? So it is in imaginary axis, okay? So phase is the this side angle. So it will be 90, okay? So the phase of C1 will be 90. And phase of C2, that is 1. So C2 is also located in real axis. So the phase is 0. If it is minus value, the phase will be 2 5, okay? Because you have to consider, you have to calculate this angle, okay? So if it is minus value, it will be a 180 phase, okay, or 2 5 phase. Okay? But here it is 0, okay? So for 0, you have a 0 phase. For C1, you have the 90 phase. And 0, you have again 0 phase, okay? So this is the phase plot. So you can plot the magnitude plot, phase plot, and if I ask to plot the spectrum, so what you have to do? You have to get the square, magnitude square, okay? And you have to plot it, okay? So you have K here, 0, 1, 2. Then you have to get the magnitude square. So this will be 3 square. This will be C1 square. This will be C2 square, okay? So 3 square, C0, 3 square, it will be 9. C1 square, it will be 3, 2, that means 9 divided by 4. C1, 9 by 4. 9 by 4. C2, it will be 1. C2, it will be 1. 1. Okay. Here, C2, C1 is 3 divided by 2. C2 is 1. Okay. C2 is 1. Okay. So this is the spectrum. Okay. So this is the magnitude plot, phase plot, and this is the spectrum. We call this as a spectrum. Okay. Anyone tell what is the importance of this? What is the importance of this? Actually, if we see this in a spectrum analyzer, we will have this one, okay? So this spectrum is what? This is spectrum, the magnitude square is what? This is the power of the signal, okay? This is the power of the signal, okay? So I will try to arrange a lab for you, okay? So you can understand this very well, okay? So this 3, okay? Actually, this is we call normalized power, okay? Normalized power. So this if so you know that if we have a 3 volt, okay, 3 volt, and if it is sent to a resistor, okay, you know that the power will be 3 square divided by R. This is the power, okay? But if you consider this R is equal to 1, so this will be 3 square, okay? So this 3 square is the power dissipated through a 1 ohm resistor, okay? So normally we called it as normalized power, okay? Normalized power. So that normalized power is here. If you get Fourier coefficients and if you get the spectrum, that is the power of that normalized power of that component. Okay. So this will be the so in the spectrum analyzer, we can see the frequency component, and also with respect to frequency component, we can plot the power, normalized power. So that plot is given by a spectrum analysis, okay? Okay, so that spectrum is important. This is how we can calculate it, okay? So these are power of each component, okay? The power of this component, DC component, is 9, and power of this DC component is this 1 square, that is 1, and power of this component is also 1, Power of this component is 3 square by 4. That means 9 by 4. This one also 9 by 4. Okay, but we no need this one and this one. We will have only this plus value. 9, 1, 9 over 5. This is the normalized power. Okay. Actually, spectrum analyzer, the is that is shown with respect to omega. Okay, not k. Okay. So here the omega is 458. Okay. Okay. Omega is 458. 45. And here the frequency is 0. And here the frequency is 25. Okay. So 0 you will have 9. 25 you will have 9 by 4. 45 you will have 1. Okay. So this is the plot we can see using the spectrum analysis. Okay. So that is all I think. Okay. So I think now you should be able to find the Fourier series representation of any signal. Okay, if we are given any signal, you should be able to find the Fourier series representation. Okay, so redo this question also. This question also. Okay, so do these 3 questions, and if you have any problem, you can ask me. Okay, so this the solutions are there. You can verify the solution. Okay, so if you couldn't get the solution, you can ask me. Okay, so try to do this example. And also in Shom outline books, I have uploaded it to the LMS. Okay, so in the Shom outlines book also, you can see many example. Okay, you can see many example. And also you can see that in mid semester exam also this kind of mm, question is given. So you can try that one also. Okay. Okay. So try to do that one also. Okay. Then from Shom's outline books. Okay. If you get Shom outline books. Okay. So you can refer this chapter 6, solve problem. Okay. So there are many solved problem. Okay. So I think as I can remember, we have done this one. So please do this one and try to plot magnitude plot and phase plot for this signal. Okay. And also this kind of signal also you should be able to. So try to do this one also. This example also try to do. Okay. And the answer is there. Okay. So that's all I think. Okay. That's all. I think that's all. Okay. So try to do that examples. Okay. I have shown you. Okay. So if you have any problem, please ask me. Okay. So today we will stop. From today we will stop Fourier series representation. And next week we will move to Fourier transform. Okay. Fourier transform. Okay. And we will do some question. Okay. So we will do some Fourier transform example in next week. Okay. So now we will stop. Okay. So try to do that example I have shown you. Okay. To familiar with the process. Okay. To familiarize with the process, please try to do that question. So shall we stop now? If you have any question, you can ask me. Okay. Or if you doesn't have any question, sorry. Please don't leave. Wait, because you need to give the attendance. Okay, that is very important. Don't leave. Please wait.